Pesticides are compounds designed to be toxic to target organisms. Their usage has improved crops quality and agricultural production. However, negative environmental impacts and health risks have raised due to their frequency of use in a wide variety of application settings. In addition, their physicochemical properties can enhance their persistence. Ozonation is a modern advanced oxidation process based on the use of ozone, a strong oxidant agent capable of removing a large variety of organic pollutants. Two main interactions take place during ozonation. Pesticides molecules can directly react with molecular ozone or indirectly with hydroxy radical, which is a secondary oxidizing agent generated during ozone decomposition. Ozone can also degrade organic matter, decreasing pesticide absorption and favoring their elimination. This work has evaluated the use of ozonation for the removal of free strobilurin fungicides in soil, azoxystrobin, pyraclostrobin, and trifloxystrobin. Preliminary experiments were carried out in a greenhouse situated in southeast of Spain. 120 cylindrical containers were prepared with 3 kilograms of polluted soil and introduced inside the greenhouse. Then, the soil was exposed to different treatments during 50 days. These treatments were S treatment, soil covered with polyethylene film, SOS treatment, soil covered and exposed to ozone in the gap between the plastic cover and soil surface, SOD treatment, soil covered and exposed to ozone at 8 cm depth from soil surface, and a control that is soil without any treatment. Experiments at field scale were performed in a greenhouse equipped with 15 parcels. After filling the parcels with the soil previously contaminated, 5 different treatments were conducted during 50 days. The 4 explained before, and a 5th one, the SODS treatment, where soil was covered and ozone was simultaneously applied at surface and at depth. The film cover tool was impermeable to ozone, acting as a gas barrier and avoiding possible fluxes of this gas to the atmosphere. At lab level, fungicide degradation fitted well with a first-order kinetics. Figure 1a depicts the degradation curves of the fungicide studied in different soil treatments. In general, SOS and SOD treatments produce higher degradation rates than those observed for control treatment. For azoxystrobin and trifloxystrobin, SOD treatment resulted in greater degradation rates in relation to S and SOS treatments. In the case of pyraclostrobin, no significant differences were found between these treatments, probably due to the higher rate constant of this compound per se that could disguise the effect of the treatments applied. At field scale, the application of ozone to soil covered in these 3 treatments improved the rates of fungicide degradation. The reactive species, ozone and hydroxy radicals, appears to be mainly responsible for the increased pesticide removal. The remaining percentage of strobilurin fungicides obtained for the different treatments after 0, 25, and 50 days are represented in Figure 1b. The comparison of the 3 ozonation treatments shows that SODS is the most efficient for the degradation of all the fungicides. Thus, the residues found in SODS soils after 50 days of remediation treatment were below 0.2 ppm, whereas 0.5 ppm were recovered from the control soil. In general, the remediation efficiency increased according to the following tendency. In conclusion, the higher degradation rates obtained for ozonated soils show that this technology could be used for pesticide removal at field scale, being the efficiency of the process likely to be increased if the technique were performed in a season with higher levels of solar radiation. Finally, this work was supported by the European Commission through the Life Plus program, Life Iron Soil project. Thank you very much for your attention.